Hi everyone, I'm Stefania Chaplin, aka DevSecOps. I am a solutions architect at GitLab, and today I'm going to talk about securing microservices, preventing vulnerability traversal. You can also check me out on my different social channels, which I have at the bottom, so feel free to connect. I'd love to hear your thoughts, feedback, etc. So, agenda. A little bit about me. Who am I? What are we here to talk about? I've got quite a famous example I'm going to talk you through. I'm talking about vulnerability traversal within microservices. So who is our audience? Thinking about the silo of the teams that we need to work with. How are we going to approach this? How do we fix this? What are some frameworks that we can use? I'm also going to look at some specific types of vulnerabilities. And most importantly, why? Why are we here? Why are you listening? Why am I talking? Why are we looking to secure our microservices? A little summary and then Q&A at the end. So who am I? I used to be a developer, mainly using Python, Java. I did a lot of work within REST APIs. I'm one of those, I say cool or weird. I'm one of those cool people that I can just read JSON. That's the way my mind works. So if you need a particular value, I can tell you the order of square and squiggly brackets to get you there. Then I moved to the wonderful world of security, focusing within DevSecOps, AppSec, and also CloudSec, so securing our cloud and microservices. And now I work at GitLab, the DevOps platform. So if you do want to talk to me about GitLab, I love talking about it. But this talk is not a GitLab one. As you can see, DevSecOps. Outside of that, I do surfing, I do a lot of yoga, and I have a lot of tropical plants. I also like being in the tropical jungle. Right now I'm in Nicaragua because I've got great surf, yoga, and tropical plants here. So back to my talk. What are we here to talk about? And I want to start a bit with a story. And I say a story, it wasn't that long ago. It was the week before Christmas. I lie, it was a couple of weeks before Christmas, but I'm not sure if anyone remembers or came across Log4Shell. Could be the worst software vulnerability ever. And this headline was not alone. There were lots of equally strong headlines about this. So I'm going to talk to you. So Log4Shell was related to a component called Log4j, which is a Java component used as a logging framework. And it's very, 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 very popular. It is used in a lot of different types of applications. And the thing about this vulnerability is there is a vulnerability scoring system from 1 to 10. This was a 10. So this was as high as you can get. And when we think about components, for example, Log4j, if anyone has come across XKCD before, I would recommend it. Really good, very, very clever IT-related entertaining images. So here we have, this is August 2020, all modern digital infrastructure. And then at the bottom, that little, a project some random person in Nebraska has been thanklessly maintaining since 2003. That little component, that is Log4j within this context because it is a logging framework used, I'm not going to say by everyone, everything. However, Ernst & Young and Wiz did a study and they actually found that 93% of cloud environments are vulnerable to Log4Shell. And what they found, 45% like security protection, 20% have high privileges. That's awesome, but that also means that 80% do not. And 7% are exposed to the internet. So you've got some real risk there. And just to remind you, this Log4j, Log4Shell, it was a 10. So this is obviously quite a big deal. So the vulnerability scoring, what does it mean when it's a 10? So I've got a screenshot here. It's a little complicated. I can kind of talk you through it, but It's based on a number of factors. So I have configured it here. We can see the attack vector. For example, can I do it via a network or do I have to be physically there? Similarly, attack complexity. Is it easy or is it hard to complete this vulnerability? And similarly, do I need privileges, user interaction, etc.? So we start to have these different scores, and I would check it out. It's CVSS calculator. And you can start to play around. So this example, I can do it on a network. It's not hard. I don't need any privileges or user interaction. That's going to be a 10. So what does that actually mean? We have this calculation. The way that it is ranked is you have your criticals. So they're your 9 and 10s. And in terms of prioritization, this is where you want to start. I've worked in application security a long time, and we always say, you know, start with the 10s. Just start there. Then go down to the 9.9s, the 9.8s. They go to 1 decimal place. And hey, you fixed all your 9s. Awesome. Okay, let's move. Let's go to the highs. Because what you'll often find with vulnerabilities is you can actually start to link them together. For example, a high, maybe this is a denial of service. Medium, you're probably not worrying too much. I have a nice, bumblebee. However, these are things like path traversal. So if you get into a directory and you manage to get in somewhere, if you can move around, what happens when you end up in the etc folder? Oops. And then we want to get to a happy world where we only have lows. And ideally, we want to remove those too, but we want to work our way down. Have your line in the sand and keep moving that number lower, and also have security checkpoints as you go. And I'll talk about that a bit later. So why Log4Shell could be the worst software vulnerability ever? Hopefully now you can get a better understanding. It was a very common component, and it was a very high vulnerability. It was very easy to execute, and the way it was accessed was before any authentication. And that was the thing, poor Log4j. So if you think of the person in Nebraska, this is how the Log4j maintainers felt, because after the critical, that was a remote code execution. So someone could go in and execute code remotely. Then next came a denial of service. So that was fixed in the version 2.16. Then came another denial of service, so fixed in 2.17. And then finally, another RC, another remote code execution. So you've really got a mix, and that's just this one component. So when you think about your microservices, unfortunately, it might look a little bit like this. You're going to have bugs all over the place. And what we're trying to prevent is, here I have Log4j. And maybe it's got in within a particular process, within a particular service, for example. And then what happens if it starts moving around and all of a sudden it's within your main application, within your critical data? So what we really want to do is we want to have checkpoints that we prevent this vulnerability traversal and our beautiful ladybugs from getting into our microservices systems. So common pain points. Log4j, how do you know what is where? And also on this, how do you prioritize? Siloed teams, so lack of ownership and accountability. Do we know the person that creates the service, do they then own the service? Are they responsible for security? Who owns what, for example? And then delays, fails, or worse. So what this means is you don't want to have any bugs in your system, but then what happens when something goes down? We hope in a microservices system, you can, fix things quickly, patch quickly, scale back up quickly. But what happens if the bug moves around? And also, what happens if your team is spending the majority of their time fixing bugs or doing patches or fighting fires? You really don't want to have that from a cultural perspective, in terms of careers and attrition as well. And ultimately, you do not want to be front page because of a vulnerability, because that obviously has massive impacts for brand as well. So who are we talking about? I'm going to talk to you about my silos. I'm really talking about the main three. I do have one over there. Sometimes that's corporate. But let's focus on these three. I've got my developers. So they might be provisioning microservices. They might be provisioning environments. They might be running the applications within the microservices. So they might be developing processes. They're usually going to be the ones, writing the code. And developers, I used to be one. We like new and shiny. We tend to be quite intelligent, quite creative, and we like to stay kind of within our tools and within our world. Then you have security. Now, security are usually outnumbered. So I've seen different ratios. I've visited a lot of different organizations in my time in security. And one time I spoke to an organization, they had about 130 devs and 2 security, so 165. And I was like, I wanted to applaud them because I was like, that's the best I've ever heard. Because on the opposite end, I'd been to places where it's 300 to 1 AppSec. And similarly, when you've got tens of thousands of developers, okay, you may have a larger AppSec team, but there's always going to be quite an outnumbered ratio. So one of the things I like to think about is how can we empower developers? How can we get them everyone to be 1% better? I'm a big fan of compound interest and incremental gains. So I'm not saying we want security to become developer and vice versa, but maybe let's start to break down these silos. Let's start to be on the same team. Let's start to work together. And finally, you have ops. And whilst dev likes their new and shiny, ops likes stability. Literally measured, one of the, well, not KPIs, but one of the areas of importance is reliability, availability, latency, uptime. So ops wants things to be stable. And, square pegs, square holes, sometimes devs come along with this weird circle, weird shape, and there can be a bit of an issue there, and DevOps is great for that. But what I'm really talking about, it's not a case of buy all these tools, do all these processes. It is more of a case as well, about culture and about, changing how we work together, because we are all on the same team. And it's not about the bad guy, who did this, who did what. When there is a situation, how do you deal with it? Is there psychology of fear? Like, is there culture of fear? Or is it more proactive? Okay, there's a problem. Who knows what? How do we fix it? And then afterwards in the deep brief, how can we do better next time? Because when you have these 3 groups, they're kind of tribes. They speak differently. They have different influences, different importance. So it's very much about getting everyone to kind of work on the same team and work together, because you don't want to end up like this. So here I have my ops silo is not doing so good. It's a little bit broken, because what might have happened somewhere within our environment, there might be a crypto miner that got into one of our Kubernetes instances and has spawned 200 pods. We're maxing out our AWS bill, and ops has been paged in the middle of the night like, what? What's going on? How do we fix this? So what we want to do is, have a more proactive approach, kind of think more securely. Secure by design. I like to talk about that a lot. So who owns what? This is a very good place to start when you think about microservices, because you really ownership and accountability is very important. Sorry, I'm just going to take a drink in a bit. Okay, perfect. So Martin Fowler did a very famous article, 9 Components of Microservices. And one of the ones he talked about was cross-functional teams, because also when you're working, instead of having your tribes like my silos before, it's like, hey, why don't we do cross-functional teams and organize around capabilities? So we organize around products. So instead of having a project mindset, we go to more of a product mindset. So I'm like, okay, this is the mobile app team, or this could be customer login, or however it might want to be. But with these cross-functional teams, where is security? Do we have a security within each team? Do we have one spread out between 5? Could we maybe get everyone to be a little bit more secure? How can we facilitate security? Because it's a lot of worry in a CISO's life, I'll tell you that much. So it's very much about thinking who owns what and where is security within all of these processes as well. And prioritization, this is a very important one to think about. So high risk, start there. And whether that's the types of vulnerabilities or whether that is the types of applications, you want to go for your high risk and your high exposure first. So if anyone's come across Eisenhower decision matrix, I actually use this for productivity, but you want to think of your 4x4, urgent and important. So guess what? If something is urgent and important, like maybe a critical vulnerability, you're gonna want to do that. Similarly, if something is important but not as urgent, plan to do it. Like maybe those would be your lower vulnerability bugs, for example. And then if it's not important, not urgent, you can delegate, if it's urgent but not important, delegate. And if it's not really urgent or important, is it worth your time? Because I'm sure there's a lot of other things you should or could be doing that are urgent and important. So this applies not only to day-to-day life, but also to vulnerabilities as well. And it's also worth mentioning false positives, because unfortunately, they do come across. They can come along, when you have security, there can be instances where there are false positives. So what I say when those come across is see if there is any way that you can kind of sanitize your results, because developers don't really like being given false positives. So see if you, if you're working with security tools or vendors, how many false positives are you getting? Is it like 1%? Is it 99%? Is it an issue? Is it not? Also, how do you identify them? How do you know that something is a false positive? Because the person who says it's a false positive, not saying I speak from experience, but they might be a developer who might not have a full understanding. And coming back to my silos, that's why we want to give developers and ops and everyone just more of a secure mindset. So then you're just not introducing, these vulnerabilities. What I would say, as much as we don't like false positives, what is even worse actually is a false negative. So I personally would rather have a larger list, which might have false positives, than a smaller list, but then miss some bugs. Because then if you don't, if it's unknown, if you don't know that you've got vulnerabilities in production, then you're in more trouble than if you just have a list of false positives. So how are we going to do this? And I'm going to talk about some common frameworks. And I'm also going to go a bit granular and talk about some specific vulnerabilities. But the reason is they're very popular in security, and it'll give you a bit more of a because I'm hoping if I can make everyone in the school 1% better at security, my job here will be done. So the Center of Internet Security has this awesome framework of controls. So this is V7. I think there's just been a V8, so apologies, I'm slightly out of date. But what I would recommend for everyone, just focus on the basic. Let's start there. Especially with security, we want to build strong foundations and move our way up. So for example, the first two are just inventory and control of hardware and then of software assets. So yeah, back to Log4j. Do you know what is where? For example, Log4j, do you have a software bill of materials listing all of your open source components for all of your different microservices? Simple yes, no, maybe. Well, yes, no. Similarly, some of these other ones, for example, continuous vulnerability management, adding the security, looking at admin privileges. I'm going to talk about that in a bit. Configurations, and also maintenance, monitoring, and analysis of logs. Logs are so important. As a developer, I didn't like writing them. I just found it a bit tedious. As security, I'm like, oh my God, that's so important, because when something does go wrong, and unfortunately it probably will, you really want to know what is happening. So if you have someone bad in your system, what are they doing? And if you don't have logs, and if you're not monitoring, then you're not really going to know. So they could do a lot of damage. So I'm hoping if you haven't already, at least now you're inspired, work on the basic. Then we can move to foundational. There's a lot of good stuff going on there. I'm going to talk a little bit about application software security, because that's where Log4j was. But also these lessons can be applied throughout. So it's not just applications, it's the entire of microservices architecture as well. So I'm going to talk to you a little bit about OWASP, which is the Open Web Application Security. Always forget what the P is. But anyway, they do like a top 10 of types of vulnerabilities. So they just released their new one for web applications at the end of last year. And this one, I'm one of these cool people. I know my top 10. Like you could have asked me, hey, what's A6? And then I would have been able to tell you security misconfiguration, but it's changed now. But anyway, the new top 4 is insecure design. And this is a very interesting one because for one, it actually includes a lot of types of vulnerabilities. So there's actually, vulnerabilities have something called a CWE, which is like a type. And there are like over 40 types within this insecure design because you're really starting to shift or start left, looking at kind of threat modeling and thinking, okay, how can we design securely? Because it's a bit like if you have a car, you don't want to test brakes by crashing your car into the wall to see if the brakes works. You probably want to test your brakes before then. Maybe you just want to design good brakes because brakes are quite important in cars. So the reason I'm highlighting this is because this is the first time in any of the OWASPs that we've really started to think, more laterally about how we design the software. The other ones that are worth mentioning, because I'll be talking about them. So access control, I give it a thumbs up, but it basically means like, hey, you're in our system, you can do whatever you want. You don't really want to be telling everyone do whatever you want. And similarly, authentication. So this is your front door. So for example, who are you letting in? And guess what? If you're letting anyone in and you're letting them do anything or everything, you're not going to have a good time. So this is the web version, great for developing applications. Within microservices, we use a lot of APIs. And guess what? There's an API top 10 as well. The picture isn't as clear, so bear with me. We have our API top 10. And if we look at the 2 vulnerabilities I was talking about, so your thumbs up, for example, are we letting can everyone do what they want? Yes, that's our number 1 and 5. And I'm going to go into what these mean in a few slides, so don't get intimidated about the difference between broken object level authorization and broken function level, because hopefully you'll understand by the end. And also authentication. This is our top 2. So this is with APIs, how accessible, how easy is it for people to get in because you're not authenticating correctly. So authentication and authorization, what do they actually mean? I know I've alluded to it, but Okta had a great definition. Authentication on the left confirms users are who they say they are. I know, rocket science, right? Like you just want to be doing that at every stage. I always say this about security. Who can do what and how? Because with the authentication, we're looking at the who, like who are you? Are you really you? And then the authorization, so on the right, gives users permissions to access a resource. This means, okay, I've checked who you are, you're allowed to do this. I really like I have a house example. My authentication, that's my front door. And then my authorization is, once they're in, can they open the safe? For example, and you can get quite sophisticated with this. For example, you might have you might need a worker to come in and they only need access to the spare room and they have a key for I don't know, to get into a cupboard where there are pipes or something. So it can get very sophisticated, and this is what we recommend. You do not want to have an open door and permissions for everyone. So broken authentication. I'm going to go a little bit text heavy, so bear with me in the next couple of slides, but an API is vulnerable if it permits a couple of things. So credential stuffing. This is if you get a big list on the dark web of credentials and you just start like going for it, stuffing credentials within APIs. Similarly, brute force. So for example, maybe you've got a username, but you don't know the password. So you're, brute force attacking. And there is within APIs, you might have lack of resource and rate limiting, which is, how many times can you hammer an API in a certain amount of time? That's another vulnerability in itself. But when we look at authentication, we want to have it even stricter, specifically around the credentials. If you have weak passwords, weak encryption keys, and also if you're sending sensitive details in the URL, you do not want to include tokens. For example, if we think back to my beautiful picture of microservices with all the bugs. Maybe our first bug was just we leaked a token. But maybe that token was someone senior, or maybe they weren't. But once we got in as that user, we found we could actually do path traversal. We could wander around the system. So you are as strong as your weakest link, and you really want to try and lock your front door, very suitably. In terms of preventing it, so make sure you know all your possible flows: mobile, web, different links, SSO, one click, and also speak to your engineers. This is really why we need to work together, because when security are talking to development and vice versa, we are all on the same team. We're trying to secure our microservices and our applications. So, just have a constructive conversation about it without any finger blaming. Similarly, read about authentication mechanisms, understand what you're doing. There's a lot of who, what, how, and also there's a lot of standards. So don't reinvent the wheel. Don't write your own authentication. There are some really good ones out there. Because if you're writing your own, hashing mechanisms, token generation, password storage, I would recommend definitely using the standards, because they will be more secure, unless obviously you're a developer for one of the standards, but you know what I mean. Also, OWASP, they have a great authentication cheat sheet. So I have had a couple of links in this talk. So feel free to reach out to me on my channels, and I can kind of send you some of this stuff, because it is really interesting. Now I'm going to start to talk about authorization. So authentication, that's our front door. How can we let in? Okay, now someone's in the house. So looking at APIs, I want to get my information. I'm user one, I just want my data. So I get, that's this is my command, get user one. It's returned user two. All of a sudden I wanted my bank details, it's given me someone else's. And unfortunately, this is what happened to T-Mobile a few years ago. Their customer data was plundered thanks to a bad API. So this is the thing, these types of vulnerabilities, it's a sure way to start harvesting data. So how do we prevent? The thing about authorization, the real way, the real thing is permissions. So make sure that you have an authorization mechanism, you have user policies and a hierarchy. Use your hierarchy. So is everyone an admin? I hope not, because that sounds very insecure. Does everyone need to be an admin? Having your different hierarchies of who can do what and how is a definite tip, and I hope everyone can take that with them. Also, using a mechanism to check if logged in users, if they have access to perform what they want to do, because maybe someone can try and do something, but just checking, wait, are you allowed to do that? And then also, this is a fun one, like another little top tip, but use random and unpredictable values for your IDs. Because if it's sequential, a bit like I tried to get user one and I got user two, then you will, if it's more random, you will be a little bit safer. So this is object level. I wanted user one, I wanted my bank details, I got someone else's. Oops. So broken function level. So this is slightly different. So I want to get roles. So I'm a user and I want to get some stuff. So get user, maybe I want to get a list of roles, but then I got the admin access. I got everything. So this is also a real problem. So before it was objects, now we deal with functions. And this is what happened to Gator smartwatches. So this is an IoT smartwatch, and it started exposing kids' personal data. And I find as well, when companies that deal with baby monitors or kids' smartwatches or anything personal, I find it always hits a little bit harder. So how do we prevent this? Similar. Having consistent and easy to analyze authorization modules. So role-based access control, having your hierarchy. Also from a security standpoint, I know there might be some people in the audience who think, oh, but that's annoying, because that's how I used to feel. But really, to be secure, deny by default. So have that mindset, deny everything. And then when people need stuff, then maybe we kind of allow it. And look at your endpoints. So look at your endpoints and then be aware of any function level authorization flaws there might be, because you also have to look at the business logic. You might need to look at what's going on, because the reality is you can't deny everything by default, because then no one could do anything. You have to have acceptable flows. So just making sure those are as secure as possible, because something that can often catch people out, for example, Lambda, ephemeral, appears, it does a job, it goes. What permissions does that Lambda have? What can it do? Yes, it might be only available or around for 3 seconds every Tuesday, but if someone managed to intercept and then take control, and that's a Lambda between two, very important and not authenticating applications, all of a sudden, you might have a problem. So now what? So I come from DevSecOps, and I think there's a couple of lessons to be learned from there. And the main one is multiple security gates, because security isn't a case, it's not an add-on at the end. It's like, okay, we've built our microservice, now let's add security. It doesn't quite work like that. So there's a picture I'm going to show. It's a lot of information, so I'm going to break it down. But here we have Dev and Ops, and they're working together. So I'm gonna break it. So first, we're going to look at the dev side. So these are, the developers, and like I mentioned to begin with, maybe we're provisioning environments, maybe we're, writing the code, maybe we're doing the app. But let's think about threat modeling when we're planning. Maybe we want to have integrations within our developer environment, within our, for example, IntelliJ, for example, any other IDE. What application security scanning are we doing? If we're doing Terraform, are we using Chekhov or any other providers to check that our Terraform script isn't going to accidentally be unauthenticated to users? And for example, other ones, input fuzzing, integration test, maybe have a chaos monkey if you're into Netflix and you want to start destroying things, it is a good idea. And similarly, when we move over to more of the cloud, to the ops side, now we have our application, it's been tested, we've done the first half, but then, we kind of want to release it. And then we're going to start to want, to do, prevent, detect, respond, predict. And there's a lot of areas within that. For example, integrity checks, penetration tests, network and monitoring. I personally think incident response is one of the most important roles, just because at some point, unfortunately, something will go wrong. How quickly can you recover from that? And that is one of the key DORA metrics as well, is mean time to remediation. When something goes bad, if your server gets, if someone drops your table, oops, how long does it take, to get back up and running? So what you can see, there's a lot of information. If I go back to the full slide, you can see we've got, 30, maybe 40 different, security checks. I'm not going to say, well, I should say, yes, you do need all of them, but we can't all start from, having from 0 to hero. But what it's about is taking that mindset. So when you think about your front doors, when you think about who can do what, start thinking about your different microservices and how we can stop this vulnerability traversal by having security, at every stage, having it incremental, because it's a lot better for example, if it's a lot better for me to figure out I've got a problem in my Terraform script when I see a Chekhov scan versus when it's in production because we've just been hacked because I wrote bad Terraform, for example. And the truth is, and this is a great quote by someone called Brian Foote, if you think good architecture is expensive, try bad architecture. And the same is true for security. So if you think, all those tools, you're like, wow, how much is that going to cost? Okay, yes, security isn't cheap, but also neither is being on the front page. And especially in the last year, 2 years, we're seeing this massive rise in ransomware, for example. It used to be that people would just take our data, for example, I think it was Marriott Hotels, Equifax, lots of customer data. But now what we're seeing is, okay, now you've got ransomware, now you've been owned. So it's the same approach to security, where you really want to try and have good security and add that to your already good architecture. And why? Why is this important? Why are we here? Why do we care? So microservices are awesome. Well, I think so. Pros and cons, obviously. But what you end up with is cross-functional teams, which are also awesome, and develop, test, problem solve, deploy, and update services independently. So instead of a monolith, you can scale, you can configure, at the microservice level. So this will lead to faster deployments and troubleshooting turnaround times. So when we add security, when we shift left with security, so for example, the Terraform example, using checkoff scanning, or having app scanning as we're writing our different processes, this will mean less downtime. It'll also mean less frustration, because developers, actually, I don't think developer security operations, no one likes having bugs. No one actually likes them. Security sometimes like finding them, because then it's like, okay, I found a bug, job tick. But actually, we don't want to have bugs. And especially with the frustration, if you find that your team is spending their majority of the time, firefighting, dealing with everything, you're going to be having a bad time. So if you shift left, you end up being able to deliver better software faster. And all of a sudden, if you can deliver faster, if you've got less downtime, if you can listen to your customers and you can hear what they're looking for, and you can deliver it quickly, and you can innovate and you can iterate, all of a sudden, you're going to start outperforming your competitors. And doing this all together will drive true business value. So to summarize, prioritize high risk and high exposure vulnerabilities. Start with the 10s. Unfortunately, I'm sure, unfortunately, you might have some. So go have a look around. Let's start there, then the 9.9, 9.8, etc. Think, who can do what and how? Is our front door locked? Is it closed? Are we rejecting people from doing whatever they want? So that can be applied in, everywhere in the world of security. And so as you're going back to your day jobs after this talk, have a real think about, in terms of with your microservices, how easy is it for malactors to get in, and what can they do? And once you've that, having multiple security gates. So where I come from, DevSecOps, think about having this iterative approach to security so that you don't end up with, hopefully, any high risk, high exposure vulnerabilities. If you are specifically interested in Log4j, I work for GitLab. We wrote this great blog about it. You can see the link here. I can share it with you afterwards. Also at KubeCon, we do have a stand. So yeah, feel free to visit us there. And thank you so much for listening and coming to my talk. So if you do want to stay in touch, or if you want to have me talk for any of your talks or your companies, speak to me at stefania@devsecops.com. You can find me on my social channels at the bottom. Similarly, if you're interested in GitLab, that's where I work. I've got my GitLab email as well. So thank you so much, everyone, for listening. Feel free to reach on my channels. I love questions and feedback. And yeah, hope to speak to you all soon. Thanks.
Hi there. Thank you. That was great.
Thank you so much. And thank you, everyone, for being interactive in the channel. I had to keep scrolling up to make sure I was answering all the questions. So thanks for being engaged.
I think you have answered all the questions that anyone had posted. If anyone's got any other questions, please do post it in the chat, because we've got about another 10 minutes before the end of this session. Anyone that's already asked the question, if you want to follow up, also do that in the chat. While we're waiting for that, though, I might just ask you a question myself, which is, I guess, have you got any more advice on how you get developers to feel responsible for security, or to care about it?
Yeah, it's a bit of a tricky one, especially with security. It's almost like passing the hot potato between different personas. So something that can be really effective, I've found, with developer groups is I have another talk about this. It wasn't in this slide, wasn't here, but two things: make it fun and make it automated. So when I say make it fun, what you can do is you can have, for example, like an internal hackathon. It could even just be, an afternoon. And what you can do is you can either have red team and blue team, or put everyone on the red team. And what normally happens is you end up with the senior developers, and then they normally know about a few skeletons in the closets, so they find bugs. And then especially with the junior developers, that's something like, is it this easy?
And that can be real, like, oh, wow, maybe I really should care about security. Because also with security, there's been a real change over, say, the last kind of 5 years. It used to be if you got hacked, all of your personal data or customer data, for example, would go, which is obviously very bad. But now it's a case of you hacked ransomware. I was actually talking to someone literally last weekend who works in IT. Their son's actually autistic and loves hula hoops. And because KP Snacks got hacked by ransomware a few months ago, he could not get hula hoops to his son. And his son was like, Daddy, these are not hula hoops. So anyway, with the way that security is moving, ransomware, you really do not want to be hacked, because then it starts to become serious decisions. So first point, make it fun. The second one, automate it where you can. I really like the question about the IDE plugin, because you want to shift left. You want to get it within the existing developer workflow. You don't want to have a case of where you're going through line by line. You want to have a case where a tool goes through line by line. You get your results. The results are then delivered to a developer in a way they understand. And ideally coupled, you can also get secure coding integrations. I used to work at a company called Secure Code Warrior. So what will happen is if a developer is told, oh, it's insecure deserialization, what does that mean? Well, actually, that's to do with the way that it breaks down from bigger options, down to the stream. So yeah, helping developers understand of the importance of security, making it fun with like a hackathon. And also with the hackathon, you don't even have to have real prizes. You could have you could have an Uber Eats voucher. You could be nice. You could have an iPad. But even recognition is so important. So for example, a letter or an email from the CISO or the VP of engineering. Well done for your activity in hackathon. And some people want public recognition, some want private. So also kind of doing that as well. But I think definitely awareness, carrot and stick with it. And where you can, make it fun and make it automated as well.
I would just comment on that we did I worked somewhere where they did something similar, and I was a bit nervous about doing it, but it was so much fun, and there was so much guidance on here's what you can do, that it was absolutely great, and everybody really, yes, I second it. It was really fun. We've got a question saying, we have Black Duck, White Hat in our CI/CD. Is that enough, or should we be thinking about other tools also?
So I'm familiar with Black Duck. I don't know White Hat as in, could it be Red Hat? Could it be White Source? Or maybe White Hat is a particular product I may not be familiar with. So Black Duck, from my knowledge, focuses on open source. And so that might be the components that you're getting from Maven Central or PyPy, etc. And that is one piece of the puzzle. So for example, I'm just going to do a little plug for GitLab. So what we often say within our pipeline, you have static code analysis. That's the code the developer writes. You have your open source. So that's what Black Duck is doing. We do dynamic application security testing. So, are you leaking anything in headers once it's a running application? Secret detection. Are there any API keys or any other credentials, out there? API fuzzing, if you've got APIs, especially microservices, that's so important. Code quality. I think I said secret detection. I know there's about 7 or 8. I wish I had my little GitLabs live in front of me. But Black Duck, it's a great place to start, and all developers use a lot of open source. But there is really a very big piece of the puzzle. And I'd say one of the benefits of using GitLab is you get all of that testing in one place, and you get all the results in one place. So then the developer, at the point of a code commit, can run their security scans. They can see, oh, oops, I added Log4j version 217. That still has lots of vulnerabilities. I need to upgrade to 219, for example, or whichever the latest version is. So yes, it's a good place to start, but I would recommend thinking about having other security tools. And if you want to speak to me about GitLab, yeah, you've got my details.
Okay, we have one more question. So as we create a platform with security first in mind, we do perform penetration testing twice a year via a specialized third-party company. What is your thought on that? Is it too much? Is it not enough?
So it depends if that's the only thing you're doing. And because you've said you create a platform with security first in mind, to me, like if I just read the first sentence, I'm like, oh, okay, you're thinking about the secure design that I mentioned at the beginning. Maybe you're doing, threat modeling. You potentially got the security in the IDE and then all the others in the CI/CD. So if you have a security first approach and then you've got, you know, security integrated, then yes, pen tests, you know, they're good, but are they enough? I've worked with an organization, and what they did, they were actually using Veracode, that's another static code analysis, and they would go to the pen testers and say, these are the bugs we already know about from our security tests. We want you to find the advanced ones. And I think that's where pen tests really comes into its element, because, you know, you've got your low tier easy bugs, and that's where you can get the, you know, automated security tools. And you want your pen testers to really try and find some weird and funky angles, you know, similar to, say, like bug bounties. For me, like the difference between pen testers and bug bounties, it's almost the same skill set. It's just different people doing it. So what I would say, I don't know enough about the rest of the security you're doing. If you're only doing pen tests twice a year, I'd say that isn't enough, and you want to, you know, look at some of the other approaches I mentioned. If you already have everything, then yes, I'd say twice a year, or like every couple of months is a good amount. Just make sure they're focusing on the advanced pen testing.
Great, thank you for that. And we are actually nearly out of time. Thank you so much, Stefania, for joining us. We will be having a hangout with a speaker after this. So if there are any more questions, please do come there and get a chance to chat to Stefania a bit more. Thanks,
Awesome.
everybody.
Thank you, everyone, for joining and listening. I hope you've enjoyed the session.